Good day, everyone, and welcome to our presentation on operating system analysis and recommendations. My name is Rayan Bajura, and I am presenting on behalf of Group 1. Joining me in this project are Kavish, Hasib, and Yash. We conducted this analysis as part of our course, which is ICT 201 Operating Systems Administration, under the guidance of Dr. Hafiza Shaukat. Today, we will explore the various operating systems and their advantages and disadvantages and provide recommendations for their use. Let's begin with the importance of operating systems. Operating systems are crucial as they serve the interface between computer hardware and users, managing systems resources effectively. This presentation aims to analyze, compare, and recommend different operating systems based on their performance, security, usability, and compatibility. We will focus on four main operating systems that are Windows, Mac operating system, Linux, and Unix. The purpose of this report is threefold. First is to analyze these operating systems based on key factors like user interface, security, and scalability. Second is to compare the advantages and disadvantages. Third, to provide recommendations for different computing environments such as general use, business, and specialized applications. Now let's dive into the comparative analysis of these operating systems. We have evaluated Windows, Mac operating system, Linux, Unix based on their user interface, security features, stability, scalability, and compatibility. Starting with Windows, it's widely used in both personal and business environments due to its user-friendly interface and broad compatibility with various applications. However, Windows is frequently targeted by malware, which makes regular security updates essential. It supports a wide range of hardware, but sometimes this can lead to driver conflicts and system instability. Next is Mac operating system developed by Apple. It's known for its seamless user experience and robust security thanks to its Unix-based architecture. The closed ecosystem enhances security but limits compatibility with non-Apple hardware. Mac operating system is highly optimized for performance, particularly in multimedia applications. However, scalability is limited due to fewer hardware options. Linux is an open source operating system celebrated for its security, stability, and customization capabilities. It's commonly used in server environments where control and security are paramount. However, Linux can be challenging for beginners due to its less intuitive user interface and compatibility issues with some commercial software. Unix is known for its robustness, security, and multi-user capabilities, making it ideal for critical systems and servers. Many other operating systems, including Linux and Mac operating system, are built on Unix foundations. Despite its strengths, Unix is complex to manage and often requires programming expertise, making it less suitable for general users. In summary, Windows and Mac operating system offer user-friendly interfaces, making them suitable for general users and businesses. In contrast, Linux and Unix provide superior security and stability, making them ideal for specialized environments. The choice of an operating system should depend on specific needs such as usability, security, and hardware compatibility. Thank you.
Going to tell you operating system analysis and recommendation. So my topic for today is computer system components and control. So we will discuss about the computer system components and control. In the computer system, there are some like operating systems have a crucial function in imagining computers main part like the central protection unit, CPU, memory, and input and output devices. Whereas the efficiency of the operating system in managing these components directly impact how well the computer performs. So if we just talk about the CPU management, the CPU is the brain of the computer. So basically it executes instruction and processes data. Operating system allocates CPU time through scheduling algorithm. So if we talk about the memory management, so basically the memory management involves allocating and deallocating memory spaces to various processes. Techniques such as paging and segmentations are used to manage memory effectively. If we talk about I/O management serves to connect the system with peripherals such as keyboard and printer. So basically, if we talk about the storage management is about organizing and managing information on storage devices. Different operating systems employ different file systems. For instance, NTFI is used in the Microsoft Windows. However, if we talk about an AOS performance is a managing these elements helps to determine the overall performance of the system. Window guarantee wider compatibility, while Linux Azure better resources for administration, which is necessary in high performance and relatable system. Thank you. This is my topic, and the further topic will explained by my colleague. Thank you so much.
Hey guys, this is Yash Khangas and I am from Group 3 Melbourne, Geelong City campus. And now I will continue after Haseeb Sultan with our group assessment for ICT 201, which is operating systems overview. So I'll start with the processes, synchronization, and deadlocks. So the overview would be total process creation, scheduling, and termination. Importance of synchronization and process management. Synchronization is very important in process management so that we don't have any deadlocks or any processes that are hindered by any other processes. And we will also look at deadlock handling techniques. So moving on. First of all, we'll start with process synchronizations. So we can ensure process synchronization by the use of semaphores or the logs to prevent race conditions. In case of Linux, Linux uses controls resource access and ensures no simultaneous usage. And moving on, we have deadlock handling. So deadlock prevention and avoidance or detection is a very big issue in the computers and which needs to be done very diligently. Windows uses a method called detect circular weights, and Linux uses multiple mechanisms for deadlock management. And moving on to the inter-process communication (IPC). And IPC methods, some of the IPC methods are pipes, message queues, and shared memory. And Unix-based systems or macOS use efficient process coordination to ensure that their computers or their systems are truly working very fast as they can, and there are no bottlenecks. Moving on, we have security issues and safeguards. So importance of security in operating system design is very big thing and it needs to be done very carefully. And we will also look at overview of security features in Windows, macOS, Linux, and Unix. We will compare all of these different security features. First of all, starting with the Windows security. So Windows frequently targeted by malware, and Microsoft provides irregular updates and patches. Built-in security features which are Windows Defender. So this is a kind of antivirus which is already given to the Windows users, which is already installed in their system. And now moving on to the macOS security. And macOS use Unix-based architecture, which is very strong, which has very strong security, and which also has closed ecosystem, reduces malware risk. So they have less risks of malware attacks or any other attacks which can exploit the data or any other things of their users, which makes them highly secure. And some of the other security features are Gatekeeper or Xprotect, which is also like antivirus, which we saw Windows Firewall in Windows. Moving on to the Linux security. Linux is an open source quick fixes for vulnerabilities, so we can make quick fixes, and it also has extensive security tools such as SE Linux, IP tables, and user-dependent configuration for maximum security. So Linux is also a very secure operating system which could be used by many users and which is already being used by many millions of users. Moving on to the next is Unix security. So Unix is strong in networked environments and it uses user authentication, access control, and encryption techniques. Multiple user architecture enhances security. So these were my slides, and now my friend Kavish will move on and take over to the rest of the slides. Thanks.
Hi, I'm Kavish Man, student ID 2023-7716. So in this slide, we'll be talking about some recommendations. Based on our analysis, here are some of the recommendations for Windows, macOS, Linux, and Unix. So for Windows, it's ideal for general users and businesses due to its wide compatibility and the ease of use. And for macOS is mainly used by professionals in order for creative content who will benefit from superior multimedia performance and security too. For Linux, it is recommended for server environments which requires high control, security, and customization. In Unix, it should be chosen for critical systems needing robust stability and security, particularly in multi-users and networked settings. So in this slide, we'll be talking about the conclusion. In summary, the choice of an operating system depends on specific requirements such as usability, security, and compatibility. Windows and macOS excel in user-friendliness and integration, while Linux and Unix offer superior security and stability for specialized environments. Ultimately, selecting the right OS involves balancing these factors to match your individual or organizational needs. Thank you for your attention. These are the references used to create this video. Thank you for listening.